Student, in today's lecture, beta, I'll discuss first few numerical, which is based on a study like types of thermometers. Uh, Once I'll finish my dear numerical, after that, student, I'll start thermal expansion of matter. Right. So that's why in thumbnail I placed that is what thermal expansion of matter. So student, have a look at first example which asked by J student, that is multiple time. So student, have a look at questions. What question says? Yes, beta. So student, in the question, what is the question? Have a look. Faulty thermometer, my dear. What's the question? You can say this is lecture 2 beta. Okay. Uh, faulty, faulty thermometer. Student, a faulty thermometer. Right. Student, a faulty thermometer rates freezing point, rates beta C, freezing point, rates student, freezing point, and God bless you for your reaction, and boiling point of boiling point of water at -5 degrees Celsius and the student 95 degrees Celsius respectively. Student Jai Shri Shah, respectively. Right, beta? Okay. What is the correct value, student? What is correct? SR01 beta, viscosity class, student, I'll take 9 o'clock. Beta, this is, I can see beta, classes for thermometers, right? So your class beta, I'll take student 9 o'clock. Hare Krishna Ara Sharma beta, how are you, my dear? Very gone. Correct. Correct value. Correct value of student temperature as it reads it reads student 60 degrees Celsius. Right. So now students, I'm going to write options. Now students, I'm going to write options. Okay. 60 degrees Celsius on student faulty thermo faulty student thermometer. So student, this is option ID 60 degrees Celsius, student 65 degrees Celsius, 64 degrees Celsius, and 62 degrees Celsius. Divya, hello Vita, how are you, my dear? Okay. I can say now I'm not getting any uh, students from uh, like Sagar or NS, anyone. Okay. So I can say, hello, Ara beta. How are you? So, Bacha, this is a question here. Beta, asked by J. Bacha, J. May. Student, exactly, I'm forgetting, beta. What's the year they asked? Right. So, have a look at this question. It's not tough, it's easy, Bacha. It's literally, beta, pretty easy and scoreable in the paper hall as well. Okay. So, student, have a look. Solution. Then what's the question? Everything information related to degree Celsius. So, my dear student, we have to uh, think about only degree Celsius scale, right, my dear? Okay. So, beta ji, here, just think beta once. This is degree Celsius scale. This thing beta already yesterday I taught you how the temperature scale, how the what is that I can say student beta freezing point, boiling point. These all things beta already I yesterday yesterday. If you want to if you want to just know these all things, then you can go and watch beta previous lecture of the study class. Yes, but it's highly required everyone. So now which I can say that's buddy. This is student boiling point. This is what my dear. This is basically boiling point beta. This is beta ji. Sorry, my word. Beta, this is freezing point beta ji. Student, this is boiling point. Sir, I'm a 12th student. Still, I'm enjoying watching your every lecture with 11th to 12th. Make physics interesting. Beta, it's true na. Beta, I know. Usually, beta, I'm trying to beta, just caring each and every candidate. Either you are online or offline, right, beta? So keep beta watching the review, also. Definitely you will get benefit, my dear. Beta, God bless you, bacha. Didya beta. Now, bacha, this is what, my dear. This is what you can say freezing point. This is what, my dear. You can say this is what basically freezing point. Okay, this is a freezing point beta. This is boiling point. Beta, they mentioned question here. A faulty thermometer reads the freezing point. Beta, how much? This is beta freezing point. Beta, note down beta data. This one data beta note down according to questions only. Beta, there is mentioned freezing point is what beta is minus my dear minus 5 degrees Celsius. Beta boiling point. It's easy, but I can easily understand. Because you what 95 degrees Celsius. What is the temperature? What is the correct value of temperature as it reads 60 degrees Celsius? Okay, so it's a pretty easy, bacha. Now, beta, again, what is the standard of degrees Celsius scale? So now this I'm telling you because someone is new today. So beta, this is I'm doing this one standard of degrees Celsius scale, my dear. If anyone want to just more here, then you can go beta and watch previous lesson. Student, this is 0 degrees Celsius. This is what beta is 100 degrees Celsius. This is student Celsius scale beta representation, right, my dear? Okay. Bacha party. So what's in the questions? Have a look. Reading beta. Reading in faulty thermometer is what, bacha party? This is what 60 degrees Celsius, right? So student, there is a formula here which is remain same. I said beta yesterday, but again, student, I'm repeating. This is student. You can say scale reaching minus beta z freezing point upon beta z. This is boiling point minus beta z. You can say freezing point, right? Beta party. And this is beta. One time you have just note down beta this data. Then beta compare from here only because this is a real Celsius scale. Is equals to beta same formula. You can say this is student scale reading minus beta z freezing point upon beta z boiling point minus beta z freezing point. So what is the scale reading beta party? This is what 60 degree beta. You can write my dear. This is what 60 degree minus beta party freezing point. This is what minus minus plus. Minus minus beta plus beta. Boiling point beta 95. 95. Beta what you can say? 95. Okay. Then beta party you can do beta 95 and beta this is what? Minus minus plus here. Beta minus minus what you can say? This is what plus, which is equals to beta x minus 0. You don't know. You don't know beta what is this? So you can take beta consideration as a x degrees Celsius. This is beta c only. So we can say bacha x minus u. Let us suppose I'm considering x over here, or you can also say bacha g at x distance. At a distance x, this is what c degrees Celsius. So in better way, we can write c minus 0 beta upon bacha party 100 minus 0, right? But I will get your c value from here only. Student, you will get what c value from here only. How much coming bacha party? This is what 65. 65 upon 100. C upon 100 here. Now beta cancel each other na beta. Arthar Bhardwaj. Hare Krishna, my dear. How are you? Beta Arthar, student, your class I'll take beta 9 o'clock. Arthar beta ji, I'll take your class beta 9 o'clock. Actually beta I don't have your contact na, so I didn't update you bacha. Right. For further student, Arthar, uh, beta just simple student just once message me. Yes beta. Arthar beta once message me bacha, right? This is WhatsApp number. But once messaging my dear, here only for time update. But I have to come at 9 o'clock, bacha. My dear, I'll take your class 9 o'clock, bacha. I hope you got it. Done, Athar? Okay, fine. Uh, so now, bacha, अब look here next. Next, beta ji. What's answer, bacha party? You can say we are getting, my dear, 65 degrees Celsius. So what is the correct answer, my dear? Okay, very good. Beta, this is what? Options number Bombay. Options number Bombay. Beta, it's literally very standard question, bacha party. Literally, it's a very standard question, my dear. Okay, bacha party. Have a look next year. Next, beta, already I did in the classroom all the points. So do bacha little questions here based on this. Little beta question based on this. So what's question, my dear? Have a look. These all are basic question, beta. So keep in your mind. What are student? What are the what are the following temperature? What are the following temperature? Student, what are the following temperature? That is first student, 37 degrees Celsius. Beta, this is 80 degree Fahrenheit. And third one, you can say minus something. I'm just taking it random data. Beta, what are the following temperature? You can just beta convert these all temperature. Student, degrees Celsius, it's a temperature, but as you can see, degrees Celsius to convert in Kelvin. Degree Fahrenheit, it's a, but this is what degree Fahrenheit. So, but as we will go through this one by one. Already mentioned what are the following temperature but there is missing here something. What are the following temperature on with as the Kelvin scale? On with as a Kelvin scale. Okay, in these all temperatures are degree Celsius, beta the next beta Fahrenheit, and this is degree Celsius. Convert beta in what? In Kelvin scale. Okay, so student have a look solution. Okay, so beta this is what 37 degrees Celsius. Temperature on Kelvin bacha party easily can do bacha. Temperature in Kelvin bacha party you can easily do bacha. This is what temperature of degree Celsius plus beta Z. I hope you are all of you know 273. So temperature in Kelvin बच्चा this is 37 degrees Celsius plus beta जी 273. So temperature in Kelvin बच्चा you can take 310 Kelvin. What might be 310 Kelvin? This is beta part A. Now beta I'm going to solve here. That is part B beta. This is what 80 degree Fahrenheit. Beta what 80 degree Fahrenheit. So here beta I can use the principal formula which I said yesterday. Now again I'm writing once. This is what temperature of Fahrenheit minus 32 upon beta Z. This is, I hope you remember. This is what basically 180 is equals to temperature in Kelvin minus beta Z. You can take here 273. Remove fraction beta. This is what 100. So beta you can say cancel beta this decimal 9 times. This is what 5 times. So you can say beta 5 times temperature of Fahrenheit minus beta Z 32 is equals to beta. This is 9 times temperature in Kelvin minus beta Z to 73. Further solve here. So you can say 5 times. Okay, so this is what temperature in Fahrenheit. Beta mention for us here. 5 times beta. This is what you can say 80. Beta what you can say beta party 80. Right. Minus beta what you can say 160, which is equals to 9 times temperature in Kelvin minus 9, which is multiply with 9 3 is the 27 2 with 9 7 is the 63 plus 2 65 6 with 9 to the 18 18 plus 6 with 24. This is what you can say 2457. Correct here. 273 into 9 with 9 6 the no, I did wrong. 9 3 is 27. 2 9 63 62 63 plus 2 beta 65 6 9 to the 18 18 plus 18 24. Correct only beta. Okay. So beta this is what you can say 400 minus beta is 160. 9 times of temperature in Kelvin minus beta 2457. So beta how much coming this sir? You can say this is 0 beta. Uh, this is 4. Yes beta ji. Correct near? Uh, yes 214 here. Correct only. Is equals to beta this idea plus 2457. 9 time temperature के बचा पार्टी just simple है you can add beta this 7 5 plus 4 9 बचा 4 plus 2 6 2 6 अपन beta जी 9. So you will get temperature in what beta party Kelvin. Temperature beta what you will get in only beta party Kelvin. How much coming here anyone? Anyone answer me here 9 to the 27. Huh, 9 to the 27 here. Anyone answer me please? Sagar. Oh, you joined. Actually, I'm missing beta. Right, literally na. I was looking to you actually. Yaar. Ki Sagar, basically classes arranged for Sagar. Sagar, where is ISR like this ready, Shivang, these all bacha? NS, if possible, beta, just follow once beta, everyone. Okay, you already answered bacha party, so I'll take your answer only. That is what? Temperature beta is in Kelvin. Beta, this is what my dear? 299 is you wrote na 299.6 Kelvin bacha. Very good beta. Very good, my dear. I'm very happy here to see. Okay, beta. Now your next question, my dear. Next question, bacha party. What is the next question here? This is already part third, na? For C is it is 77. Okay, there is not a big deal here. You can easily say bacha. Temperature in Kelvin. You can say temperature in Celsius plus beta Z 273. So this is what? Minus 196 plus 273. 633. Uh, you can see बच्चा minus yeah so बच्चा goes this 13 6 7 years this is what 77 Kelvin correct बच्चा correct सागर महाराज बेटा correct very good बच्चा जी very good my dear okay बेटा after this बच्चा party just move next question से यार सागर बेटा note down question with me बच्चा सागर बेटा नोट डाउन क्वेश्चन बच्चा बेटा बीच में ओनली बच्चा एक दिन से बच्चा typical temperature in the interior of earth and sun are beta I can take here temperature of earth beta you can take 1.5 into beta 10 to the power 7 degrees Celsius. Oh, JR. Hello, bacha. How are you? Jai Sri Ram, beta. Okay, temperature of Earth, beta ji. Beta, what is the next? Beta, this is temperature of Earth, bacha. Now I'm calling beta. This is writing beta temperature of Sun, my dear. This is 1.5. I wrote wrongly, bacha. 1.5, bacha. This is 10 to the power 3. I wrote wrongly entire temperature of Earth, beta. You can say you can take beta 4 into 10 to the power 3 degrees Celsius. Beta, this is temperature of Earth here. Beta ji, this is what? I'm good, sir. How are you? Beta, I'm totally fine, bacha. Temperature of Earth, bacha, 4 into 10 to the power 3 degrees Celsius, bacha. Temperature of Sun, bacha, you can take 1.5 into 10 to the power 7 degrees Celsius, right? Respectively. Beta, what you need to find, bacha? Let's slow down, bacha, everyone. Uh, what are what is this? What are these temperature in Kelvin? Beta, same thing, beta. You can write what beta first. Find what are this temperature in Kelvin, बच्चा buddy. Beta options number B, बच्चा. In option B, what you need to find? What you need to find, बच्चा buddy? What is the percentage error, student? What is the percentage error? What is the beta percentage error? Yes, beta, you have to find. What is the percentage error is made in each case if a person forgets to change degree Celsius to Kelvin? Degree Celsius to Kelvin. Okay, answer me, Bachcha Party. Anyone from all of you? Beta, this is temperature of Earth in degree Celsius, temperature of Sun, beta, in degree Celsius. You have to convert what I can say this temperature in Kelvin. This temperature in Kelvin, Bachcha. Next, beta, you need to find percentage error. Percentage error for both of the case. You have to find percentage error of, you can save it as Earth and Sun. Because sir, how to find percentage? You don't know? Okay, I'm telling you, bacha. I hope beta you done first part, na? I hope beta you done first part, right? So still beta I'm just doing it. So beta have a look at the solution. Beta the first part. Temperature beta, these things beta we have to convert in Kelvin here. It's pretty easy. I hope you can do easily. So beta temperature in Kelvin, simple beta. Use the formula my dear. So what is the formula beta? Temperature in Kelvin. You can say temperature in degree Celsius plus 273. Now, bacha party. So you can say here this is what 4,000 basically. So you can write it here 4,000 plus 273. So temperature in Kelvin, bacha party. How much you will get here? Tell bacha party. This is 4 4 273 here. 4273 Kelvin. 4273 Kelvin. Right, bacha party? Okay. And bacha, I can say beta, let us suppose this is your temperature of Earth which I converted. So you can say temperature of Sun. You want to find in Kelvin. You wanted to find bacha in what? Kelvin. Okay. So this is what? Leave it here. This one. 1.5 into 10 to the power 7 plus beta ji 273 Kelvin. Plus beta what? 273 Kelvin. Beta for percentage beta. Just I'm going to tell you beta for percentage. Yes beta ji. How to find, let us suppose, beta initially you are targeting for part number B. Part number B beta. Percentage error can be written as percentage error. Percentage error bacha, you can write my dear. You can write my dear percentage error bacha. That is what bacha ji, temperature in Kelvin minus temperature in degree Celsius upon beta temperature in degree Celsius into beta what multiply by 100. Or Sagar beta, you can also remember my dear temperature beta what in final minus temperature initial upper beta temperature initial into 100 beta party. So no beta temperature Kelvin is what final temperature beta. How much here? I hope you remember beta party. This is tell beta party 4723 in Kelvin beta party. 47 beta party what you can say 23, right? So beta, or you can say directly beta party here, or you can say beta party directly over here. This is what beta 4723 minus beta party temperature in Celsius here. I hope you remember. This is 4000 upon beta g 4000 into beta g 100. So this is beta what you can say. This is 4723 or 4. What is the answer here? 4273. You're not telling anything, Sagar. 4273. So this is what beta is 273 into beta is 100 upon beta is 4000. Right. Sagar, solve beta further. You can see these two decimal finished. So beta is 273 upon beta 40. Beta, how much coming, Sagar? Beta, solve further here. Sagar, beta, how much coming? Can you say a 6? 240 here. 6 point. How much coming, Sagar? Okay. Okay. Very good. Very good. Very good. Sagar, approx. No, beta, Sagar. Beta, I can use. Wait. Beta Z, this is 273 by 40. 6 time beta. 4 here. So you can say this is 3, 7 minus 4, 3 beta 0. Decimal here. You can say beta 40 sati. हाँ, 8 time बच्चा 8 time बच्चा party. This is 320. So you can see 0 बच्चा 0 बच्चा party. Again you can take 0 बच्चा party. So 4 to the yes 80. 20 beta. 6.825 बच्चा. Student 6.825 in percentage. 6.825 in percentage बच्चा. But you can't say 7 approx. You can't say 7 approx beta. My sagar बच्चा. Okay. Beta the next question here. Beta similarly बच्चा you can find बच्चा. This is percentage error for what my dear? For beta this is I can say beta for earth. Student you can simply find beta for sun here. So formula remains same beta for percentage error. This is student you can write temperature in Kelvin minus temperature in Celsius, temperature in Celsius into beta जी 100 into beta जी 100 here. Further beta whatever the things you can solve. Okay. Now बच्चा जी next question here. Next question बच्चा जी. Beta you can take here. Beta we have to practice first. Thermometer beta questions here. Okay. Do beta one more last question बच्चा सागर. Right बच्चा buddy. Note down beta question with me only. If a temperature scale, student note down with question with me. If a temperature, sir, can you show before question? Yes, 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 yes. Previous question you can say. Yes, beta. See, my dear. I didn't beta calculate this one further. Beta, I didn't calculate it, my dear, further here. Right, just I wrote the formula, beta, I can do everything. Further step. So, beta, what's the question here? Next. Should I continue next question, beta, Sagar? Okay, question. Okay, fine. हाँ बेटा, if a temperature scale student defined the बच्चा जी freezing point. Defined the beta freezing point of water as 100 degrees Celsius and the boiling point as 0 degrees Celsius. What temperature on this scale? What temperature? What temperature on this scale corresponds to? Corresponds to 25 degrees Celsius. Yes, beta, answer me this question, Peter ji. What's the question? You can read once more. If a temperature scale define the freezing point of water as a 100 degrees Celsius and boiling point as a 0 degrees Celsius. Okay, what temperature on this scale correspond to? What are the temperature on the scale correspond to? JR, I'm not getting any reply from your side. Only I can say today, tomorrow only I can say Sagar will get chocolate only for this session because no one is replying anything. Yes, all are silent here. Okay, fine. Now, beta Sagar, I'm going to solve beta this question, my dear. Listen me very, very carefully. Okay, it's a not tough question, but I can say easily here. You can say easily, but what is the question here? Just read carefully here. We wish to find what temperature on this scale corresponds to 25 degrees Celsius, right? So, bachcha party, simply you can go through beta. Make diagram beta first. Student, make diagram first. Means scale here. You have to just beta make first. Bachcha ji, this is what you can say. What mentioned in the question, bachcha party? Freezing point 100 degrees Celsius. Student, freezing point what mentioned? This is 100 degrees Celsius. Now, bacha, this is boiling point. At a boiling point, what is in the question? This is 0 degrees Celsius. This is what, my dear? Sir, I think 75. Okay, Sagar beta. Wait, I'll confirm you, bacha. Right. Student, you have to just compare here this result from what standard degrees Celsius scale. So this is what, my dear? I hope all of you remember 0, bacha ji. And this is 100 degrees Celsius. Right, bacha? So just beta go through here once. So beta, I'll just equate here these two. Student, I'll equate here these two. Right? So here mention bacha correspond to what? 25 degrees Celsius. Beta, what you can say correspond to 25 degree Celsius. So bacha party simply go bacha party. You don't know this is what. Let us suppose this is X. This is known for us. How much? 25 degrees Celsius. Scale rating beta, you can say X. Minus beta the freezing point 100. Upon beta boiling point 0. Minus 100 here. This is what you can say C upon 100. And C beta mention here. That is 25 degrees Celsius. So we can put what's about it? X beta this finish here. You can say X minus 100 upon minus 1. is equals to beta. This is what 25. Beta what you can see 25 here. Beta this minus go this side बचा party. You can say x minus 100 is equals to minus 25. Oh, very good. Very good, Sagar beta. Your answer is 75 degrees Celsius. Yes. Yes, 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 yes. Yes, beta. 75 degrees Celsius. Okay. Okay. You also present beta. Okay. You also present admin beta. Very good. Now, bachas, have a look at next. Have a look at the next. Right. Very happy to see beta, Arvind. Here you are doing work beta. Very good. I can say beta in the classroom. Literally beta, you are not doing anything there. Literally beta, you are not doing anything. The math is very tough. I can't do. Okay. Okay, bacha party. Next question here. Have a look, my dear. So what is the next question, bacha party? Beta, note down question here. At what temperature? At what temperature? At what temperature Fahrenheit scale reading equal to half that of Celsius scale. Student, I'm writing question here. At student, what temperature is the Fahrenheit Fahrenheit scale reading? Fahrenheit, sir, when will you end? 9 o'clock, bacha. Jaldi 9 o'clock. Fahrenheit scale, Fahrenheit scale, student, reading equal to half that on the Celsius Celsius scale. God bless you for your reaction. Yes, beta. Answer me. Answer me, dear. Student, answer me, dear. No, yeah, math's not a tough over here, right? This is very common math. You can do easily. You can do very, very easily. Yeah. Math is not tough over there. Okay, answer me beta questions. Anyone from all of you. Sagar, can I solve this question? Sagar beta, can I solve this question? Sagar beta, can I solve this question? Okay, maybe Sagar not available. Ah, yes, beta. Have a look here. The question, student. What question says? At what temperature is the Fahrenheit scale reading equal to half that on Celsius scale? Equal to half on that Celsius scale. Bacha. I hope all of you remember here this conversion. Temperature in Fahrenheit, which is equals to 9 by 5. Temperature in degrees Celsius plus 32. I hope it all of you remember. Now, students, I can say in the question mention student, according to question, what is that? At what temperature Fahrenheit? Fahrenheit, we tell you, temperature of Fahrenheit, half time temperature of Celsius scale. Half time beta what? Temperature of Celsius scale. Right. Okay. You are here only, but why you are? It was not responding previously. I called many times. No, like beta, just replace बच्चा body. This is 1 by 2 times TC बच्चा plus sorry minus is equals to बच्चा party 9 by 5 TC plus 32. Simple बच्चा. Just solve it further here. So beta what you can say TC this beta this side TC beta I can take common here. 1 by 2 minus 9 by 5 is equals to 32 bacha. 5 to the 10 bacha. So TC bacha, you can say this is what? Shin bacha. 5 minus 18 is equals to 32 bacha. So we can say TC is equals to beta 320 by how much here? Minus 13. So TC beta how much coming here? 13 beta 2 times here. Minus beta 2 26 5 30 6 65 yes beta that's a mom beta 24.6 degrees Celsius yes beta this is DC what your answer is been minus 12.3 Fahrenheit beta in degrees Celsius answer bacha this is what I can say beta minus 24.7 degrees Celsius minus 24.6 degrees Celsius yeah 24.6 degrees Celsius bacha buddy okay next bacha have a look here next question my dear next question here okay so student what is the next question my dear okay okay very good Sagar uh in Celsius correct already okay very good beta Arvind beta I'm proud on you my dear I'm proud on you my dear good next question bacha buddy what is the temperature for which reading on Kelvin and Fahrenheit scale are same what student what is the temperature for which student what is the temperature for which the reading on Kelvin and Fahrenheit. Sagar, sir, I am now faster than. Okay, I'll see. What is the temperature for which the reading on Kelvin and Fahrenheit scales are same? Then answer me, no? Answer me. Scales are same. Bacha, what is the temperature for which reading on Kelvin and Fahrenheit scales are same. Fahrenheit, beta, God bless you for your here. Fahrenheit scales are same. Now I'm solving with party. Your calculation is faster than Google calculation. Very good. Okay. So what question is that? According to beta questions, what says what is the temperature for which reading on Kelvin and Fahrenheit remains same? Simple, Navacha. So you know your Kelvin is what? K temperature in Kelvin minus beta G 273 upon beta 100 temperature beta in Fahrenheit beta minus 32 upon beta G we can say 180 here beta both are same so you can say x beta x minus beta G 273 upon 100 x minus 32 by 100 here cancel beta this is 5 beta this is 9 you can say this is what 9x minus beta 9 273 into 9 here so this is 9 3 the beta 27 2 bacha 9 7 the 63 to 65 9 to the 18 plus 2457 student this is 2457 is equals to beta 5 multiplier this is so what I can say bacha this is what basically 5x minus 160 beta come this side here so you can say 9x 9x minus 5x is equals to 2457 minus 160. So this is a beta 4x beta. Just beta calculate 160 beta subtract over here. So this is 7 beta 11, 15, 6 beta ji 9. This is 3 1 ja 2. 2 बचा जी. So you can say 2297. So x beta ji 2297 by 4. So x literally is here 4 5 ja 20. 2 9 divided 4 7 ja 28. 1 बचा 4 4 ja 16. 4 4 ja 16 बचा बाटी. 4 7 ja 28 है ना. This is wrong. So beta 574.6 degree Fahrenheit. What's your answer, beta Sagar? Oh, very good. 574. Your answer is 576. How it changed? How? Oh, no, no, no. It's, I can say, Arvind, not Sagar. Not Sagar. Arvind, your answer, beta. Check once, bacha ji. There is variation here. My answer 574 point. Yes, something beta like this. Okay. Beta, what we have taken here? Because I have taken as a 273. Maybe there is a variation. Listen, listen. Okay, okay. Okay, beta, Arvind. Now, beta, have a look at next questions. Have a look at the next question here. Okay. The next question here, you can say an accurate student. Have a look example here. Student an accurate Celsius thermometer. Celsius beta G thermometer and a beta faulty Fahrenheit beta faulty Fahrenheit thermometer beta J thermometer resistor thermometer beta what resistor 60 degree and 141 degree respectively. This is what, my dear, respectively, right? Okay. When student when placed placed when placed in the beta G same constant temperature student same constant temperature constant temperature same constant temperature enclosure. Okay, beta, it's literally a very good question, bacha. It's literally beta a very good question, my dear. Sir, I don't know, sir. Okay, okay, don't worry. How to do questions faulty thermometer. Faulty beta, I can say, Arvind already explained one question, my dear. Actually, it was absent on that one. Beginning of today class. Yes, beta, this is a question, beta. This question, bacha, asked by JE, bacha, multiple time, bacha. And faulty thermometer, definitely they will ask. Beta J, faulty thermometer, beta J, definitely they will ask. Right, my dear? Okay, don't worry, beta. Have a look at questions. Here only. Beta, what's the question here? When placed in what same constant temperature enclosure? Enclosure, bacha, pati. Beta, full stop. What is the error in the Fahrenheit thermometer? Student, what is the error in the Fahrenheit Fahrenheit. Sir, can you move the book little right side? Yes, 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 yes. Yes, 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 yes. Yes, beta. Got it, got it, got it, got it, beta. Fahrenheit thermometer. Beta, this is Fahrenheit thermometer. Yes, beta. It's literally good question here. An accurate students, an accurate Celsius thermometer and a faulty Fahrenheit thermometer register 60 degrees Celsius and 141 degrees Celsius respectively. When placed in the same constant temperature enclosure, what is the error in the Fahrenheit thermometer? Okay, so that we have to find error here. Student, we have to find what's the error. Which God bless you for reaction, my dear. Student, we have to find what's the party error. Okay, bacha. So come, student, everyone. So how, student? Listen me carefully. It's not a bit. It's easy question, right? But yeah, there is a bit of concept to solve this question. Okay. What's in the questions here? Beta, I can say this is what an accurate Celsius thermometer. So beta, we can take for consideration with the Celsius thermometer. Okay. Yes, beta. Now bacha, I did. Beta, so initially bacha, just keep in your mind. My dear, this is what? Degree Celsius. I hope beta you remember. C upon 5, which is equals to beta F minus 32 upon 9 beta. I hope all of you remember, my dear. Sir, can you adjust the angle of your phone? I can't see questions full. Okay, is it fine beta? Sagar, I can see beta. Sagar now. Sagar now beta. Is this fine now? Any problem beta, Sagar? Sagar beta, any problem? Arvind, is it fine beta now? Position of beta, I can see notebook. Okay. So beta, first we can find here beta Fahrenheit temperature. So bacha, beta further here. What's the mention in the question, bacha party? This is what 141 degrees Celsius. So bacha ji, you can first find what is the Fahrenheit temperature, bacha. So degree Celsius mention bacha. How much? Beta degree Celsius mention bacha ji 60 degrees Celsius. Beta feet over there. So this is student 60 upon beta ji 5. 60 upon bacha 5, which is equals to beta, you can say f minus 32 upon 9 bacha. This is 12 here. So this is beta, you can say 108, 40 beta. You can say beta, this is f is equals to 140 degree Fahrenheit. 140 degree Fahrenheit. Uh, okay, okay. Wait beta, Sagar beta ji. Wait beta ji, Sagar. Beta, f is what you can say 140 degree Fahrenheit. Beta, we wish to find error here. Student, be ways to find error. So what is error, bacha? This is 141 minus 140. So you can say this is what? 1 degree Fahrenheit. So error beta, you can say in reading here in Fahrenheit is what, bacha? 1 degree Fahrenheit. Correct, yeah. Correct, it's Sagar beta. You already answered. Sir, can you adjust the angle of already? Is it fine, na, Sagar? Okay, fine, bacha, party. Error, bacha, what? Beta, you can see 1 degree Fahrenheit. Okay, beta, they also ask here. I can say, what is the error? Beta, they can ask, beta, this is one more question. Student. Now I'm going to add over here. Beta, ji, they can also ask correction. Student, they can also ask correction here. So this is what, my dear? Correction, beta, what? Minus 1 degree Fahrenheit. Correction beta, what you can say just beta opposite. Beta error is positive bachcha, so you can say what? Correction is negative bachcha ji. Error is positive beta, so you can say correction is what? Negative beta. What you can say? Minus 1 degree Fahrenheit. Minus bachcha party 1 degree Fahrenheit. I hope you got it, beta. Both of you, Sagar and I can say Arvind. Okay, beta, take snapshot, beta, student. Then student, I'll change the page. I wanted to beta turn the page. Okay, okay, fine. Okay, now student, I'm just going to here. Huh. So beta, have look next question, beta party. Have look, beta party. Next question here. Beta, again you can beta note down questions. Faulty thermometer. Yes, beta. This is the question, my dear. Uh, faulty, a faulty thermometer reads reads melting point and boiling point of water, melting point and boiling point of water as student you can take -1 degree Celsius and 104 degrees Celsius. Yes, beta. The temperature of a body, the temperature of a body is measured. The temperature of a body is measured as 20 degrees Celsius on that thermometer, on that thermometer. Beta full stop. Find, find the true temperature of body. True temperature of body. Yes, beta. I hope this question literally visible for everyone here. Mhm. Yes, beta. Now, Bachaji, everyone, answer me. Anyone from all of you? Student, anyone answer me here from all of you? Okay. Come to the point, beta. Solution. Have a look, everyone here. What's the question? A faulty thermometer beta reads. So, beta, first you need to draw. Student in step one. First, no, beta. There is no any possibility of error in the paper hall. Student, first you have to make diagram. So, student, let us suppose now I'm doing faulty thermometer. So this is what, my dear. Beta, this is what, my dear. Minus faulty beta versus melting point. Correct. Melting point, freezing point. -1 degree Celsius. Then beta ji, what is boiling point? Student, this is the boiling point. So beta, this is what means 104 degrees Celsius. Okay. The temperature of the body is measured. Okay. So beta, again here, you can just beta first this one. Beta calculate from temperature of body beta how much? Temperature of body is measured 20 degrees Celsius and that of thermometer means beta. I can say faulty. You can say bacha party, this is what faulty beta. On faulty thermometer bacha, what they measure 20 degrees Celsius. You can say this is the scale reading. Beta G, you can say at any value of x, this is what 20 degrees Celsius. Simple bacha. You can draw standard temperature scale of degrees Celsius. So this is what, my dear? I hope all of you know this is 0 degrees Celsius, and this is beta the boiling point 100 degrees Celsius. Okay, now what's party for this condition? What you can think, beta? Simple, beta. You don't know what's the temperature over here. So, beta, here you can take. So, we wish to find true temperature. Let us suppose at any value of x, temperature is T bacha party. So, beta, first write scale reading bacha. Just equate these two. So, beta, I'll write first here scale reading is what? 20 minus minus plus. Beta, 104 plus 1 is equals to bacha T upon 100. T upon 100 bacha party. Okay, so this is beta what? You can see 21. 21 upon beta 105 is equals to T upon 100 beta. I can say multiply by 5s. Beta, this is 5 times finish here. So temperature is what coming with party? Temperature student. This is coming beta 20 degrees Celsius. This is what, my dear, 20 degrees Celsius. Okay, you already answered. Sagar, very good, very good, very good. Tomorrow I'll give you chocolate for both of you. Don't worry. Sagar and Vita, I can say that is what Arvind. Very good, Vita. Very good job, both of you. If you both of you doing very good job, bacha. Okay. Bacha party. Next question, sir. Next question, bacha party. Just keep in your mind. Beta little here. We have to do beta on basic thermometer here, right? So beta, wrote down questions are given. Both of you, beta. The reading corresponding to student, the reading, student, the reading, the reading corresponding to ice point and steam point. As I said in classroom today also here, ice point and student steam point. Ice point and beta, what you can see? Steam point for a constant pressure beta. Student for a constant pressure, gas thermometer, gas thermometer R R beta G. You can take 50 degrees Celsius. 50 degrees Celsius, no. You can take 500 cc, 500 cc and 545 cc. If the if the reading corresponding to room temperature be 510 cc. Student, find the room temperature. Find the room. Sir, when will you teach about 6 minimum and maximum thermometer? Already I taught yesterday, beta. Okay. Now, beta, answer me this question, sir. The reading corresponding to ice point and steam point for a constant Pressure gas thermometer. Five steam. This is ice point. This is steam point. If the reading corresponds to this is a temperature. Simple, yeah. Just straightforward, yeah. Which straightforward, Vitaji. Just you can answer me. Straightforward, answer me at these questions. I hope it's you remember here. This is what beta I can say. Beta ice point. Beta how much? 500 cc. Beta ji boiling point. 545 cc. Beta what is reading here? Reading also mentioned na bacha. This is 510 cc. Beta we have to find temperature here. Student, I gave the temperature formula here. This is what my dear scale reading minus beta ji freezing point upon beta ji boiling point minus beta ji freezing point. So beta what is the temperature here? This is beta 510 5 multiply by 100 here. Don't forget my dear 510 beta ji minus beta ji 500 upon beta ji 545 minus beta ji 500 multiply by 100 beta. Multiply by what my dear 100 only. Okay. So bacha, what you can say this is what? Only bacha 10. Temperature is what? Okay, sir, 200 by 9. Okay, 200 by 9 bacha. How bacha ji? This is what? I'm getting beta 45. So this is what? 1000 by beta ji 45. Right. So you can say beta 9 times. Correct beta ji. Correct Sagar beta. 200 by 9 here. 200 by 9 beta degree Celsius. Very good. Very good. Okay. Maybe I can say Arvind also answered these questions correctly only. Very good, beta. I'm very happy to see my dear, both of you dear. Okay, fine. Now, bacha, have a look next question here. Beta ji, have a look next question, bacha, buddy. A constant volume gas thermometer. Beta, I'm not giving all, beta, I can say every time, bacha ji. Student, here I'm not writing all questions. I can say entire length here. Beta, I'll give you directly beta data. You can take beta. A constant, just I'll write basic point. What, my dear? This is constant volume gas thermometer beta, right? So pressure reading beta, yes, beta pressure reading beta you can take 50 centimeter and 90 centimeter. Okay, bacha ji, what is data? You can take beta volume, constant volume bacha. So volume beta ice point beta volume you can take, this is 50 centimeter. Beta what you can say 50 centimeter. Okay. Now bacha you can take your freezing point. Sorry, I see. Boiling point beta ji. You can take bacha ji. This is means beta. You know this is what mentioned here. This is mentioned. You can beta keep in mind centimeter of Hg. Beta boiling point. You can take my dear 90 centimeter of Hg. Right. Okay. Beta reading here. What is the reading beta? You can say bacha party pressure reading bacha party. This is what beta I can say constant volume here. So this is the pressure reading bacha everywhere. This is the pressure at ice point, pressure at boiling point. Pressure reading bacha party. What you can take any random data here. This is 60 centimeter of HG. Answer me bacha party. Student anyone from all both of you beta answer me. I can say both of you only available today. Okay, so beta, just I'm going to use your formula as I said in the classroom. PT minus beta is what you can see, beta freezing point upon which is pressure at beta g boiling point minus which is freezing point. Don't forget here multiply by 100. So this is PT beta. You can say 60 minus 50, 60 minus 50 upon beta g This is 90 minus 50 into beta the 100 here. So beta, how much will you get? 60 minus 50 beta. This is what? 10 upon beta the 40 into beta the 100 here. Finished. 25 degrees Celsius. Temperature beta, you will get 25 degrees Celsius. Barrier Singh, sir, wind viscosity. 9 o'clock beta. Barrier beta, 9 o'clock. Barrier beta is 9 o'clock, my dear. Actually, beta, I didn't inform you, bacha, because I don't have a source to inform you. I inform only, beta, I can say, like Suvir, right? So, Suvir also carry three persons, Suvir, Sanchit, and Rashid. You have to also carry beta 2 to 3%, bacha, at least with you. Now, bacha, this is question here. So, beta, just have a look. Next, bacha, resistance beta. 9 o'clock sleeping time. Then you can go and sleep. How life, yeah? 9 o'clock sleeping time. So we will come with three people and you are going to sleep. Okay, go and sleep. Enjoy. You join the this session at least like this session, bacha. Like this session, bacha. At least, but yeah, go and sleep, beta. It's your choice. Yes, beta. I can say Atharva will come. Subir, Sanjit, Rishit, and SR01. These five people will come. Now, bacha. Next question here. The resistance of beta platinum wire. Student, resistance of platinum wire bacha 115 ohm at what? Beta resistance of platinum wire bacha 15 ohm at beta Z 20 degrees Celsius. Right. And this wire is put in a hot furnace and the resistance of the wire is found to be beta, I can say just after putting beta, I can this is initial condition at what 20 degrees Celsius. At what 20 degrees Celsius. Now, bacha, I can say bacha ji for next question here. Are beta what just after putting in the furnace, resistance beta of same wire beta. What you can see this is what 40 ohm. But bacha 40 ohm, right? Find the temperature of the hot furnace. Temperature beta we have to find here. So, today beta I give a straightforward formula only here. Alpha you can take bacha ji. Alpha you can take 3.6 10 to the power minus 3 per degree Celsius. So simple you can apply formula and beta ji. R final year already I gave. So bacha ji you can say how can you do bacha? Listen carefully beta. Again I'm repeating here. Beta resistance of platinum wire 15 ohm at 20 degrees Celsius. I hope you got it. Resistance bacha party 40 ohm. We have to find here. We have to find here what is the temperature. Let us say this is a T1 beta. We have to find temperature T2. Alpha beta mention beta for this question. Alpha beta C mention for this question, my dear. Okay. So beta, I gave beta 2D formula in classroom. R final is R initial. 1 plus beta C alpha delta T. I gave into the classroom beta T. But what's interesting point? Beta R final mentioned here. So beta I can take here in case 1. If T1 is equals to beta, T1 is equals to 20 degrees Celsius. So we can write this as R final is equals to R initial. 1 plus alpha into T1. Beta say equation number 1. Beta in case number 2, my dear. What you can say, my dear? This is what T2 here, we wish to find. So R final bacha again you can write here. R final R initial 1 plus alpha into T2. Equation number 2 bacha. My dear, just divide. Student, just divide, my dear, these two. So beta divide first by second. The student first by second, my beta. Okay, so first beta what you can say this is R final is equals to R initial 1 plus alpha T1 bacha, and this is R final 1 bacha. You can say R final 2 beta. We wish to find. Already this is mentioned bacha. We wish to find T2 here. So R initial 1 plus alpha into T2 beta G. Now you can say beta G. This is cancel. R final 1 bacha mentioned here. This is we can say beta 15 upon बच्चा जी 40R is equals to 1 plus beta alpha. How you can write? 3.6 into 10 to the power minus 3 बच्चा जी T1 beta T1 how much here mentioned 20 degrees Celsius beta take beta in Celsius only बच्चा जी take beta in Celsius only why because beta this is mentioned in Celsius बच्चा party so just multiply by what beta 20 अपन बच्चा 1 plus 3.6 10 to the power minus 3 into beta जी you can say T2 now beta what you can say 5 3 are 15 and 5 8 are 40 5 3 are 15 and beta 5 is a 40 here so we just beta I wanted to just continue with that party Arvind 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 okay now beta have a look here next God bless you my dear for reaction beta and this is what beta 3 by 8 is equals to 1 plus beta 3.6 here 72 1 plus 7.2 into beta g 10 to the power minus 2. Upon which the same here 1 plus beta this is what you can say 3.6 into 10 to the power minus 3 into t2 beta just beta do cross multiply. So beta this side beta you can see my dear this is 3 times 1 plus 3.6 into 10 to the power minus 3 into beta the t2 is equals to 8 times 1 plus 7.2 10 to the power minus 2. Okay, so just beta just open the bracket which is so this is what you can see 1 3 beta the 3 only. Sir, can we take delta t? You can take beta t1 same na bacha. Delta t1 you can take. Delta t2 you can take bacha. You can take bacha. Beta 3 1 ja 3 plus beta 36 here. This is what you can say 10.8 into bacha ji 10 to the power minus 3 t2 is equals to beta this remains 8 here. So 7.2 into 8 bacha. How much? 7.2 into 8 here. 8 to the 16. 1. 56. 57. 57.6 बचा buddy. Beta, this is what? 57.6 10 to the power minus T2. 10 to the power minus 2 beta. Okay, further here, beta come this side bacha buddy. This one. So you can say this is what? Basically minus 5. Is equals to beta what you can say? 57.6 into 10 to the power minus 2 minus beta take yeah, minus 2 this one also bacha party you can take 1.08 into beta 10 to the power minus 2 into beta g what you can see t2 right this beta do further here so beta g what you can say uh, further student for this condition solve beta g further beta 10 to the power minus 2 you can keep it out minus 5 which is 10 to the power minus 2. So this is beta 57.6 minus 1.08. Here bacha, don't forget here. This is what T2. Further solve bacha party. Further solve bacha, you will get answer. Student, you have to solve further bacha, you will get answer bacha party. Further solve beta, you will get answer bacha party. Okay. Now student, I'm going to start with the thermal expansion of matter. Thermal expansion of matter bacha. Okay. Okay. Good, Arvind beta. So now next reading bacha for today class. Thermal expansion of matter. This is what my dear? Thermal expansion of yes beta. Uh, this is bacha party. Thermal expansion of matter. Right? Okay. Come to the point. So beta ji, I can say for thermal expansion of matter, which what is the things which you can keep in mind? When matter is heated without any change, what my dear? When matter is heated without any change in its state, it usually expands according to what is the atomic theory of matter. So, Vicha, I can say for this condition, Vicha, thermal expansion, beta totally. Thermal expansion, beta defined for what? Solid, liquid, and gas as well. Thermal expansion, beta defined, which as the solid, liquid, and gas as well. So, beta first everyone here note down beta party definition of thermal expansion. Beta everyone beta note down definition beta party for thermal expansion. Thermal expansions can be defined as note down with me everyone. Thermal beta G thermal expansion can be defined can be defined as the change in thermal expansion can be defined as the change in its, or you can say better this, change in the beta length, width, change in the length, width, height, or volume. Student, volume of any material on beta on changing changing the temperature, on changing the temperature. What would we have preferred for this chapter? No, we have, I can say, content bit already. Acha, entire quiz content I have it already, right? So books, not at all, Acha. No any books. These all things why I'm telling because it's a live season classes. So here I have to write because if I'll just say and go though, so because someone maybe like and not like Acha. That's why I'm writing everything Acha. But orbital, you can also say, simplest way, thermal expansion can be defined as the change in the length, width, height, or volume of any material. Sir, for exam, already now you have textbook of Narayana. You have never already with a textbook of Narayana, my dear. Uh, so, bacha, I can say, beta on changing the temperature. Okay. Or beta, I can also say, Sagar beta, my dear. Or beta G, the tendency of matter. This is simplest beta body. The beta G the tendency of matter to increase. The tendency of matter to increase in length, in bacha party, length, area, length, area, or volume when its temperature increases. When it's beta what? Temperature increases. When it's beta temperature increases. When it's beta what? You can say temperature increases. The tendency of matter to increases in length, area, or volume when its temperature increases. So, bacha, just keep in your mind, my dear, thermal expansion, beta G, thermal expansion of thermal expansion defined thermal expansion defined thermal expansion student for defined solids, liquids, gases. Which are the solids, liquids, and gases. Okay. Now, bacha, order of thermal expansions can be written, bacha, but in which has a more thermal expansion, bacha, but because of the beta, beta gases has a more, then liquid, then solids. Then, bacha, what you can say? Solids. So, beta, keep in mind, bacha, party, this point as a note. You can just beta for note beta G. Yes. Uh, Student. You can write Vitaji in note. Order of thermal expansion can be written as Vitaji. This is what you can write. Order of Vitaji thermal expansion can be written as Vita. This is what you can say gases Vita. This is liquids. Then Vichaji, what you can say solids. You can ask Sagar Beta, sir, how these all related. Betaji for gases here, because the particle in gases are far apart and can move freely due to big intermolecular forces. You can write Bacha party for gases here. What it I can say? Because because the particles in gases are far apart, far apart, can move freely, can move freely due to due to weak intermolecular forces. Intermolecular forces. But what you can see, weak intermolecular forces. Okay. Now what's about it? This is what intermolecular forces, right? Next, beta, you can ask Sagar Bacha. What about I can say for such solids? Yes, beta. This is what I can say, beta. For solids, you can say simple, bacha. In solid, have a what? Strong forces. Simple, bacha. In bacha ji, solid have strong forces. In solid have beta, what you can say strong forces. Yes, beta. Now, bacha party, everything here. Just beta, note down. I hope done with that party. Now, beta, put the heading here. Detailed study of thermal expansion of solids. Beta, after this beta party, put the heading beta. Detailed study of beta. You can say thermal expansion of beta G. Detailed study of thermal expansion of solids. Beta G. Detailed study of beta. You can write thermal expansion of solids. Okay, fine. Uh, beta G. This is my dear sir. Oh no. No, 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 beta. No, 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 beta. No, bacha. Detailed study. No, beta, Arvind. Don't repeat, beta. detailed study. Sagar is a very good boy, beta. Always, no, I can say doing good work. Detailed study about, detailed study about, beta. This is, anyone new bachcha just like beta video here? Beta like beta video here? Literally, you can see beta Sagar. Detailed study about beta Z, thermal expansion of solid. Thermal, beta Z, this is thermal expansion of solids. Yes, beta. Now, beta, next year. Beta, detailed study about beta thermal expansion of solid beta party. So, beta, before going to start with this topic here, beta, there I can say thermal expansion of solids is different for isotropic and anisotropic material. What is student? Thermal expansion. Beta, note down beta, start with me, which about quickly one. This is Lalitesh. Oh, very good, Lalitesh, beta. I'm very happy to see my dear. You will get tomorrow chocolate. So, bacha, I can say, no, you did not answer any question. No, you will not get any chocolate. Answering why only you will get chocolate, beta. Beta, note down, bacha, note, beta, NOT note. Thermal expansion of solids is different for student. Thermal expansion, beta ji, thermal expansion of solids is Lalitis bacha, like the system bacha. Lalitis like system bacha. Thermal and so reaction bacha. Lalitis so reaction beta and like system bacha. Thermal expansion of solids is different for isotropic beta. Isotropic and anisotropic solids. Anisotropic solids. Beta thermal expansion bacha. Sir, will you take class? Yes. Yes, beta. Yes, beta. Yes, sir, 01. I'll take bacha. 100%. 100% bacha. Because, beta, I maximum joined here like just few minutes ago. Bariya also came. So, beta, Atharva also came here. So, I'll take your class, bacha, party. Very good, beta. Very good, Lalit is bacha. So, reaction, bacha, party. Lalit is. Okay, thermal expansion of solids is different for beta isotropic and beta anisotropic solids. Anisotropic solids, bacha party. Okay, now you can say, bacha, uh, Hare Krishna student. Other words was beta 9 o'clock. All beta this. I'll stop this live session, bacha. Then other beta I'll start 9 o'clock. Beta next session for beta I can say for your class. Beta isotropic material students. Iso isotropic material. Yes, beta. What you can say, beta, Pandit? Isotropic material, those materials that have the same physical properties in all directions. Student, again, I'm repeating here. What is isotropic material? Those material that have a same physical properties in all directions, meaning their strength, elasticity, and other characteristics is what remains same beta. Example, beta, you can take beta for isotropic material is what beta? You can say glass, plastic, metals, crystalline materials like diamond, etc. Right? Students, again, I'm writing beta. Yes. Just beta, 2 minutes, beta, 2 minutes. Hare Krishna, Athar, beta, just only 2 minutes, buddy. Isotropic beta, next I have one concept which I party. Isotropic material, those material which are party that have a same physical properties in all directions, meaning their strength, elasticity, and other characteristics are uniform. Example beta, I can take glass, plastic, uh, beta, I can say diamond. These all are beta what? Isotropic material. Next which I party, there is one more. बेटा anisotropic material. बच्चा जी, this is what, my dear? Anisotropic material. This is, बच्चा जी, aniso बेटा जी tropic material. Yes, beta. So, what is anisotropic material, my dear? You can say for this condition, those material have a has a properties that different according to what directions of measurement. Beta, what's the similarity here? Beta, for this condition, beta, directions remains same. Beta, here, beta, what we can say, directions, beta, different, beta. You can take example as a graphite, wood, carbon fiber, etc. etc. Bacha party. So this is all about beta. I can say basics of this. Beta, by tomorrow, I'll continue from here, beta, as usual. Now, student, I'm going to stop, beta. This is a live session, bacha. I'll start, beta, next session for next class. All the very best. I'm very happy to see everyone in live session at Physics Point. God bless you all, my dear.